Okay, we're gonna continue where we left off from the first part. I had to record this video 4 times because of an error, so I hope this is going to be the final time I explain only this second part of the video. So I'm very tired, but let me explain anyway. We're gonna continue we're gonna continue from the first part. If you haven't seen that video, please I recommend you watching that first part of the video. Um, the link will be under the description. So yeah, you can watch that first before watching that, or else you won't understand anything. Now I'm going to be talking about balancing equation. Okay, when radioactivity happens, the nucleus gets unstable, and the nucleus before the decay is often referred to as the parent nucleus, and the new nucleus formed after the decay process is known as the daughter nucleus. And we can write this decay in an equation. Okay, the parent will be the parent nucleus will be on the left side of the equation, but the daughter nucleus will be on the right side of the equation. That's to put it simply. Okay, um, we will you will see an example of the equation here later in other part of the video, so you can see what I mean clearly. So now I'm going to introduce the three type of radiation that I said in the first part of the video. We have alpha particle, we have beta particle, and we have gamma ray. Okay, uh, okay, and here is all the features that you need to know for the radiation, for each type of radiation. What kind of features they have to know, and you do have to memorize them, but we will be going through them as parts as I carry on in the next video. So I will break them down. I will break down their features and tell you what you really need to know about these features, okay? But let me just give you the basic idea. We need to know about balancing equation, okay? So first you need to know about the nuclide. You might read this in your book. You might see this in your book a lot. It's basically an element in the middle here, and the nucleon in the top, and the proton number in the bottom, okay? Uh, an example of a nuclide is here, helium. In the middle, we got nucleon in the nucleon number in the top here, and a proton number in the bottom. And like I said in the last part, I taught you about what is a nucleon number, what is a proton number, what is a proton number, what's it going to called if it's in a polar form or non-balanced form. A proton number is equals to the electron number if the atom is balanced, and if the atom is balanced, we're going to call that atom, or we can describe the atom as a non-polar atom. If the proton number is not equal to the electron number, it could be positive charged or negatively charged, then the atom is non-balanced, and therefore we can call the atom polar. And so what will happen if another atom will join to that atom because it's unbalanced. But that's basically what it is. Okay, don't get confused what a nucleon and a neutron is. In chemistry, I've heard that neutron and nucleon they do kind of sound the same, but they have a difference. Okay, a nucleon number is the total sum inside the nucleus. The neutron is only part of the neutron. A proton and a neutron are together in the nucleus. So if you're confused, look back in the other part of the video. You'll see what I mean. But we're going to continue. We're going to talk about the decaying process of each radiation. Okay, so I've already explained this 4 times already, but to put it simply, I'm going to summarize everything in just one table here. If you read this and you understand this, then that means that the decaying process for each alpha particle and beta particle, they will have the opposite number of the nuclide. If you recognize the pattern, like say example here, in alpha decay, the nucleon number decreases by 4 and the proton number decreases by 2. If you look at the symbol here, in the nuclide here, you can see the top nucleon is 4 and the bottom is proton number 2. And what's gonna happen after it's been negative, when the number has become negative, then that means that the nucleon number will decrease by 4 and the proton number will decrease by 2. See here, nucleon 4, it would decrease by 4 because it will be negative 4. It's opposite numbers, okay? It's changing the form. Helium has a positive 2, so it will minus 2. It will decrease by 2, okay? So that's how you memorize easily. Okay, let's look at another example. In negative beta decay, the nucleon number is unchanged and the proton number increased by 1. See here, electron has 0 nucleon. That means that we can't change it to positive or negative, so it's still going to be the same. But the bottom number is going to be opposite, so it's going to be positive 1. It's going to increase by 1. The proton number is going to increase by 1. But positive beta decay is going to produce a positron. That means that we have the opposite number of positive 1, which is negative 1. So it's going to decrease by 1, okay? So positive beta decay, the nucleon number is unchanged because 0, and the proton number is going to decrease by 1. And in the gamma ray, there is no change in either nucleon or proton number, okay? Effect of electron, I forgot why I wrote this, but the charge, you might see a property in the table. You can memorize this if you want. It's your choice because they have different charges, but I really recommend you memorizing the symbol because you can memorize the number of nucleons as well, which you do have to remember. Okay, so memorize the symbol, alright, and it will be the opposite numbers of the nuclide. Okay, now I'm going to talk about this. Oh, this is talk about my last recording. So, the state of the element right now, let's say, no, not let's say, but in this graph state, it's here, the state of the element. Oops. Here. And after an alpha decay, the element state is gonna minus 2 proton number, and it's gonna minus 4 nucleon number, okay? Remember where it's nucleon number and remember where it's proton number, okay? It's gonna be here, okay? It's gonna minus 2, and the proton number is gonna minus 4. Therefore, the nucleon number, the element state is gonna be somewhere here. While the beta decay, it's gonna plus 1. This is a negative beta, by the way. So when you have a negative beta decay, it's gonna plus 1 electrons because a negative beta decay produces negative electrons. Therefore, it's gonna plus 1 proton here. So it's gonna move to the right one. If it was a positive beta decay, it will move to the opposite side because it produces a positron, which is a positive electron. And then when you have a positive electron, it's gonna minus by 1. Refer back to the sentence, refer back to the symbol to understand clearly. But we're gonna move on. Okay. Now I'm gonna talk about something that I haven't. It wasn't explained in the book, but it was important to know for the syllabus. Okay. Now we're talking about the state of the particle. Okay. In each state. The particle, let's say proton, a singular proton, say 1 proton. If you think about it, imagine an atom that only has proton in it. So how many charges is going to be? I said in part 1 that the proton is a positive charge. So it's going to plus 1 charge from the proton, if we're talking about one proton. Okay? And the proton lies in the nucleus. So there's going to be 1 in the nucleus. The total mass is only going to be 1. Okay? So that's it. That's how you remember the nuclide of the proton. The nuclide, proton in the middle, and the top nucleon is going to be 1, and their charge is going to be positive 1. Okay, now we talk about neutron. A neutron has 0 charge because of quarks, and I'm not going to talk about quarks now because it's going to be it's going to be in the next videos. In the next it's going to be in this chapter, but it's going to be quite a little bit far off from this part of the video, so you don't have to worry about why is that has 0 charge. This is something you should know by now. A neutron has 0 charge. That's all you should know. And you do need to learn about this, but we're going to talk about this later. An electron, okay, oh sorry, I forgot to explain that one neutron also resides in the nucleus. So there's going to be 1 in the nucleon. If we're talking about one singular, remember, forget about the proton, forget about the electron, only 1 neutron itself in the atom. So the nucleon is going to have 1, but the charge is going to have 0. Therefore, the nuclei is going to look like this. In the electron, okay, it's going to have 1 negative charge, negative 1 charge. But like I said, if we're not focusing in other particles, we're not talking about proton, we're not talking about a neutron, we're talking about the electron itself, then it's going to be a negative 1 charge. And if you saw this, an electron has a positive charge, that means that it has a different number of this, but it's a different elementary charge, and we're going to call that a positron, but we will learn that in the other part. But that's it for this part. I'm sorry if I uploaded too late. I had to record this test like 4 times, so it took me like 2 hours to finally complete this. But I hope you understand this part of the video. That's the main idea right now. I will upload tomorrow at 8 p.m. That's what time I normally upload. But yeah, I'm going to leave it until here for tonight. So I'll see you in the next part of the video.